Okay, in these last two questions, it's still the same directions as 9 and 10. We want to find the area between the two curves. We don't have two x values here, x lines, the vertical lines that we go between, so we're going to have to find where these things intersect. If we didn't have a calculator, we could go ahead and set the y values equal to each other. So we could say 2 root x equals x squared over 4, and we could solve for x. We could multiply both sides by 4, which gives us 8 root x equals x squared. We would go ahead and then square both sides. So we could do squaring both sides gives us 64x equals x to the 4th. And solving this, we could subtract x from both sides, or 64x from both sides, and factor out an x. And you have x cubed minus 64, which, if you remember from before, factoring this cubic function, this is a difference of cubes because 64 is 4 cubed. So we would have x minus 4 times x squared plus 4x plus the 4 squared, which is 16. Also somehow typing a bunch of things on my calculator. So this won't give us any real numbers, so this is not what we need to be concerned with. Well, we still could do quadratic formula to find that. I'm sorry, I shouldn't say it that way. So we know x equals 0 and x equals 4. We can use the quadratic formula for this part. So we have negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 1 times 16. So yes, it will be imaginary numbers, so all over 4a, but we have 16 minus 64, so that's going to give us imaginary numbers. So x equals, should have written this down here. So x equals 0 or 4. So we can do that by hand, and those will be where the two places where these two graphs intersect. We do know what they look like also. We have a square root function, so that's going to look like this. We have a parabola. Let's do that in red. So in red, we have a parabola. It's going to be fairly wide because it's the same as 1/4 x squared. So 1/4 x squared looks like this. And so we just found that they're crossing at 0 and at 4. So the integral we want is the integral of the upper one. So in this case, the blue one is the upper one. So 2 root x minus the lower one. So minus the x squared over 4 dx. And that's going to be evaluated from 0 to 4. So that's what we want to type in our calculator to find the integral. We could do it by hand. So over here, I found the x values where they intersect. My guess is you're going to want to do it this way because you can just type them in here. So 2 times the square root of x is our first function. Our second function is x squared over 4. You can graph them. You can easily find the intersection here. So the x value is 4 and the y value is 4. And here on the regular TI calculators, you would have to use the calculate intersection button, which I believe you're familiar with, but probably a lot quicker to do it on a graphing calculator if you have that available. So now you would just want to evaluate this function or this integral. So let's go ahead and math 9. We're going from 0 to 4. and just typing in this integral right here. This is going to be our area. So we want 2 times the square root of x minus x squared divided by 4 dx. Hit enter, and we get 5 1/3 units squared. All right. And then looking at number 11, same idea. This time, instead of, we still could do it, and we still could visualize this sum. This one's going to be a little bit harder to graph or to know what the graph looks like. So we'll go ahead and graph both of these. We'll do that one in blue. So this is x cubed. So x cubed minus 3x, x cubed over 2 minus 3x is the first function. The second function is x squared over 2. So x squared over 2. We can graph these. We can see where they intersect. So it looks like 0, which definitely makes sense. And then at x equal to 3. Remember, we want the x value, not the y value. So our integral for this one is going to be, in this case, the red function is higher. Actually, I'm sorry, we need to look at a couple things here. Coming over here, we have 3 intersection points. We have -2, 0, and 3. And so in this first part, from -2 to 0, we have to think which function is higher. So from -2 to 0, the blue function is higher. So we're going to integrate the blue function. Let me mark these again. The blue function, which is x cubed over 2 minus 3x, minus the red function, which is x squared over 2 dx. Let me write something else out here. The area is going to equal this, so the area will equal. That gives us the first part. So let me just, so I can write on it. Here's our parabola. Here's the cubic function. So that part we just, that integral, this integral right here, gives us this section in here. Blue was higher than red. But now, moving on to the next part, we're going to integrate, and this one is going from 0 to 3, I believe it was. And this time the red comes first because the red function is higher. So that is x squared over 2, and we're going to subtract. I'm going to have to erase this. We're going to subtract the x cubed. X cubed over 2 minus 3x dx. And that's what we want to evaluate. You can do it all in one equation, or you could do your different integrals separately. I'm just going to try to type it all in one here. So we want math 9, the integral, we're going from -2 to 0 of x cubed over 2 minus 3x minus our other function, so x squared over 2 dx. Well, since I have it, I'm just going to hit enter here. So that's 2 2/3. So our first one is 2 2/3. I'm sorry, I messed up right here. We're adding the two areas together, not subtracting them. I should not put a minus sign there. That should be a plus sign. I'm sure you all caught that already. So, and then we're going to add our next integral, our next area. So we got integral, This time we're going from 0 to 3 of x squared over 2 minus, make sure we put this in parentheses because that negative will get distributed, x cubed over 2 minus 3x, end the parentheses, and then in terms of dx, so hit enter, that is 7.875. And so we're going to take those two things together. So we're going to add, so plus 2 2/3. And we get 10.54 units squared. So that's a good question to finish with. It had a couple of intersections that we needed to deal with. So those are the types of questions you'll see on your test.